again, sort of. Okay, so the question says the next greater element x in an array is the first greater element that is to the right of x in the array. We are given two distinct zero index array. We have two arrays, num1 and num2. Num1 is a subset of num2. What you want to do is you want to check num1 and you want to know the next value that is greater in num2. You could take a minute to read the question, right? But let me just explain what the question is trying to tell us to do. So the question is saying that we have to array num1 and num2. What the question wants you to do is the question wants you to go through the num1 for each element in the array. The question wants you to check the array in num2 and input the next greater element. If there's no next greater element, return input -1. But if there's a next greater element, input the value. So for example, number 4 here in nums2, 4 is here, right? And there's no element that is greater than 4, so you return -1. 1 is here, so 1 is here. The element that is greater, the next greatest element after 1 is 3, so you put 3. Then 2 here, there's no element that is greater than 2 after. No, the element coming after it, none of it is greater than 2, so you return -1. So you answer like this. Same with this example, 2, 4. So 2 is here, the next greater element is 3. 4 is here, the next greater element does not exist, so you return -1. All right, let me give another example. We have okay, so if let's say for example that we have nums1. So we have nums1. Let's say nums1 is equals to 5, 2, 3, and 6, and we have nums2 to be equals to, let's say, 1, 6, 7, 5, 4, 2, and 3. The results of my answer should give me a value of 5. What is the value of 5 here? The value of 5 is here. Is there any element that is greater than 5 after it? 4 is not greater, 2 is not greater, 3 is not greater, nothing is greater, so I return what? -1. 2, if I come here, is there any element that is greater than it? Yes, 3, so I return it. 3, if I come here, is there any element greater than it? Nothing, so I return what? -1. 6, is there an element that is greater than it? 7 is the next greater element, so you return 7. We can have, yeah, to return 7. Okay, let's add 1 here for the sake of it. So 1, what's the next greater element? The next greater element here is 6. You get 1, the value of 1 is here, the next greater element is 6, so your answer is 1, 3, -1, 7, and 6. Yeah. Okay, so how do I actually solve this? When I saw this question, what came to my mind was a brute force solution. So basically just the way I'm doing it, right? So I'm going to loop through the array and then find the index and then just go through the rest of the value and see the next greater element. If the next greater element exists, I return it. So basically what I can do is I have my results, right? So this is the brute force. I can see this is the brute force solution. And what I can do is I can have my results, and in my result I can do like a for loop from nums1. And in the for loop, what I can be doing is I will first find let's call the index. I first find the index of my value. Let's call this n. I first find the index of n. So I find the index of 5 here in nums2. When I find the index of 5, I'll now do like a remaining for loop from a range of that my index to the rest of norms 2. So I'll do a range from that my index to the rest of norm 2. And in that range, all I'll be doing is if the value of norm of 2 is greater than the value of n. If it is greater than the value of n, I just want to break from this my loop, and before I break, I'm going to do a result of results. I'm going to be basically appending the value of j, right? And if I don't find an answer here, I'm going to append. Okay, so if I don't find an answer there, I'm going to basically append a value of -1. So if none of the value here, if the for loop doesn't give me a value at all, I'm going to put a value of -1. So it's going to go from 5, find the index, then go to the rest, -1. From 2, find the index, then go to the rest, then 3, find the index, go to the rest, 6. That's going to be a naive way of finding it, and the time complexity will be about 12n squared, right? The first loop, then the second loop. In each loop, I'll be doing another loop. First of all, my first loop would be to find the index, then I'll do another loop to go through the rest of the array to find my next highest element. For example, 2, I'll go here. I first do a first loop to find the index at 2, then do the rest of the loop to find the next greatest element. Like that. Okay, so the question now says that, can I do better? Can I find a better algorithm? Okay, can I find a better algorithm? And the answer is yes, there is a better way of solving it. I could use stack to solve it. So let's look at the question again. So if I have num1 equals to 5, 2, 3, 6, and 1. If I have num2 equals to 1, 6, 7, 5, 4, 2, and 3. Okay. You know what? Let me rewrite it. Let me write it in a new place. That's the reason why I created the new place. Okay, so if I have num1 equals to, what do I give it? 5, 2, 3, 6, and 1, right? And then I have num2. And num2 is 1, 6, 7, 5, 4, 2, and 3. Okay, so what I could do is I could first of all look or concentrate on this nums2. And when I concentrate on this nums2, what I'll be doing is I would try to fill up every answer, meaning that I'll try to fill up what is the next highest, what is the next value, what is the next highest for 1, what is the next highest for 6, what is the next highest for 7, what is the next highest for 5, what is the next highest for 4, what is the next highest for 2, what is the next highest for 3. After getting my answer, I can now go to nums1, and when I go to nums1, I now take it one by one. Since I've already found the next highest for 5, I just refill it. Since I found the next highest for 2 from this array, I just put it. Since I found the next highest for 3, I just put it. Next highest for 6, I just put it. And next highest for 1, I just put it. So this is what I'm trying to say. I'm going to be using an hash map. And the first thing I'll be doing is, so I'm going to do an hash map, right? And what I'll be doing is, I will do what is the next highest for 1, What is the next highest for 6? What is the next highest for 7? What is the next highest for 5? What is the next highest for 4? What is the next highest for 2? What is the next highest for 3? The next highest for 1 is what? 6. The next highest for 6 is what? 7. The next highest for 7 is what? It doesn't exist, so I'll put -1. The next highest for 5 is what? It doesn't exist, so I put -1. For 4, it doesn't exist, I put -1. For 3, 2 is 3, and for 3, it doesn't exist, I put -1. So I have my hash map, right? This is my hash map. Then after I develop my hash map, I now go through nums1, and then my result will just be as simple as 5. I can look up 5. 5 value is -1. 2, I can look up 2. 2's value is 3. 3, I can look up 3 is -1. 6, I can look up is 7. And 1, I can look up is 6. I get my answer. You see? Same thing. Very simple. And this is a better solution because of lookup for n for nums. Lookup on a hash map is O of 1. So looking up 5 is O of 1. Looking up 2 is O of 1. Looking up 3 is O of 1. Looking up 6 is O of 1. Looking up 1 is O of 1. So developing this result is actually an O of n, because I'm going through the nums1 and I'm doing a quick lookup. A lookup. So lookup of 1 over 1. Now the main question is, how do I find this hash map? How do I find this hash map? And that is where our stack solution will come in. So finding this hash map, what we'll be doing is we'll be taking advantage of stack. And just follow through me. Just follow with me. Just go along with me as I'm doing this. So what I'll be doing is I'm going to be having a stack. Right. And in my stack, I'm going to start by I'll be going through nums2. What I'll be doing is I'll be putting in the value in my stack. But what I'll do is, before I put in the value, I'll first check the last value in my stack. If the last value in my stack, so if my current value I'm going through is greater than the last value in my stack, what I want to do is I want to take that value and update my hash map. So what I'll do is, I'll start with my hash map. I'll start by assigning the value of my hash map to -1. So 6 to -1, 7 to -1, 5 to -1, 4 to -1, 2 to -1, 3 to -1. This is how I'm going to start. So now what I'll be doing is I'm going to be looping through nums1. So first thing first, looping through nums1, I start with 1. I check, does 1 exist, right? Does 1 is 1 greater than the last element in my stack? Well, there's nothing in my stack, so no. So I put in 1. Then I go to 6. Is 6 greater than the last element in my stack? What is the last element in my stack? The last element in my stack is 1. 6 is greater, right? So what I do is I pop the last element in my stack and then I update. So I update, my value no longer is -1, my value is now 6. Then I put in the value of 6 in the stack. So what you'll be doing is you're going to go through all the stack basically. You're going to keep popping as long as the value is, as long as this condition is met, meaning 6 is greater than. Yeah. So the next thing I'll do is 7, right? So is 7 greater than the last element in my stack? Well, yes. So I pop out 6 and then I update the value 7. Then I put 7 in the stack. Then I keep going. 5. Is 5 greater than the last element in my stack? No. So I put it in the stack. 4. Is 4 greater than the last element in my stack? No. So I put it in the stack. 2. Is 2 greater than the last element in my stack? That is 2 greater than 4? Nope. So I put it in the stack. 3. Is 3 greater than the last element in my stack? Oh yes, 3 is greater. So I pop out 2 and I update 3. Is 4 greater than the last element in my stack? That means it's 3. Okay, so I've already done, is 3 greater than the last element, which is 2. Yes. Now is 3 greater than the last element, which is 4. Well, 3 is not greater than 4, so what do? I add 3 in my stack, and at the end, my hash map becomes 1, 6, 7, minus 1, 5 is minus 1, 4 is minus 1, 2 is 3, and 3 is minus 1. And that is how you solve it. So now once I develop my hash map, the rest of it is simple, right? You go through this array and just put your answer inside, and that is how you solve this. That's how you solve it. Let's just, so that I make sure that you understand what is going on in building it. Let's say I have an array that is like just maybe I have 2, 3, 1, 5, 2, 3, 1, 5, 4. Building this array, right, would be 2, would the next highest element would be 3. 3, the next highest element will be 5. 1, the next highest element will be 5. 5 will give me a minus 1, and 4 will give me a minus 1. Using this stack method, if I do the same thing, at first I'll be putting 2 in my stack, right? Then by the time I want to put 3 in my stack, I first check. So 3 is greater than 2, I pop out, right? And then I add 3. Get? So let me rewrite it. At first I'll put everything as minus 1, right? Minus 1, 5, minus 1, 4, minus 1. So 2, I put 2, then 3 is greater than 2, so I pop out minus 1 and put a value of 3. Then nothing is in the stack again, so I put my 3. 1, is 1 greater than the last element? No. So we continue. 5, is 5 greater than the last element? Yes, 5 is greater than 1. So you pop out 1 and you update it. 5. 5 is also greater than the new last element, which is 3. So you pop out 3 and you update it. 5. And then there's nothing in the stack again, so you put in your 5. Then the next element is 4. Is 4 greater than 5? Nope. So you put in your 4. And that's it. You get your array. Same thing. 3, 3, 5, 5, 5, 5, minus 1, minus 1, and minus 1, minus 1. And that's how you solve it. So let's go to the code. Right. So for the code, the first thing to do is to build your hash map. If you are using Python, there is a quick syntax where you do something like a default. I can't remember the syntax, so I'm just going to build it manually. So for I in nums2, should be? Yes. So what I want to do is I want to do build hash, and the value of I want to set it to minus 1. So this is going to first of all build my hash map and set everything to minus 1. So the next thing I'm going to do is I'm going to have a stack. And please, you can definitely write a better syntax than what I'm writing, right? Because I can do this in one line, right? I can even use list comprehension and do this in one line. So yeah. So the next thing I'll do is I have a stack, and then I go again through the array. So let's say for I in nums2, and going through it, what I'll first do is while the stack is not empty, and while the last element in my stack, right, is equals to why I is greater than the last element in my stack. What do I want to do? I want to first of all pop. So let's call the value, let's call it n. I want to pop the value out of it. And what I want to do next is I want to update my build hash and update that value that I pop in with my I, right? And after doing all that, what I want to do is I want to now take my stack and append this new value, right? And at the end of the day, it's going to build. Sorry, my indentation seems off. Yeah. at the end of the day, it's going to finish building it. So at that point now, I want to now tackle my main answer, right? Nums results. What I'm doing is I'm going to be doing for I in nums 1. So going to nums 1, I'm going to do, let's call the value, let's call it an v again. I'm going to do my build hash. I'm going to get the value in my build hash, and then I'm just going to do results.append the value. So basically, I take 4, I look for it in my build hash, and append it. 1, look for it in my build hash, append it, like that. And finally, I'm going to return my results. So if I run this, if I don't have any error, nums2 is not defined. Oh, sorry. It's nums2. How about I making a mistake? Okay. Okay, so that passed, and then okay, if I submit. Alright, and everything passed. So yeah, so to recap, you can solve it with the brute force solution where you basically go and look one by one, or better still, you can solve it in an optimized solution where you solve for nums2 first. Basically, you solve everything for nums2 using a stack. Solving it for nums2 is going to be an O of n, and then it's going to be an O of n, and then plus another O of n, which at the end of the result to an O of n complexity. Meaning that when you're solving this stack solution is O of n, right? And then at the end of the day, you do an O of n to put in your value, basically. You get? So the stack is, you put in the value in the stack, and then when you see a value, before you add that value, you first check the previous value and see if you can pop. If you're popping, you're also updating your hash map, basically. And the reason why we're using an hash map is we want to take advantage of the O of 1 lookup, basically. Yes, and that is how this question, you can solve this question with stack. So I hope you guys understand. Thanks.